different interpretations. So we're trying to create certainty. If there are a number of interpretations of a clause, we're gonna adopt one, and we're gonna put up a case of why that our view of that interpretation is correct, because we're basing it on all these standards. Now, we're not overruling the fire code. What we're trying to do is clarify where it's not absolutely clear. So, if it's not clear, we're going to use standards to support our interpretation. It's not opinion, but here goes why we think this is a correct interpretation. And then there's a system that's commonly used by engineers around the world, which is called an ARP, as near as reasonably practical. So sometimes when you have an engineering problem, it's just not solvable because the building's already built or something's happened, and there is no economic way to actually solve this problem. So an engineer will take an ARP approach and say, okay, based on all of this, based on these standards, based on my professional judgment, this is as near as reasonably practical. Now, we put that in the document to BFP as well, and we want them to come back and say, no, you're wrong here, you're wrong here, you're wrong here. That's fine, then we'll change it, but we just want to put something out there first. So yeah, they're the principles on which we are developing this whole thing. So the first clause that we're going to look at, we're starting with the simplest first, is for evacuation plans. It's actually reasonably straightforward. In the clause it actually references NFP PA 170, which contains most of the symbols that are to be used on the plan. Of those that aren't in there, you can find the rest in ISO 7010. Now most suppliers or manufacturers of evacuation plans have all these on their system and can readily go to them and make sure they're correct symbols. And then of course, once you get a plan together, that's roughly what it looks like. But doing it, there are all the things that are said to be on the plan, right? As I said, most of the symbols are in NFPA 170. Those that aren't can be found in ISO 7010, except for one. Now, we're going, what is number 7? Emergency light. So, why would I need to look at a plan to escape to know where the emergency lights are? Can't be that. Now, in another part of the code, it refers to using a series of flashlights that are not, they can't be instead of emergency lighting, but, so we've said, look, it's got to be, it doesn't make any sense that is an emergency light, it must be an emergency flashlight. So we've created that symbol. As I said, we've sent this off for approval, we've got to see what comes back, but that's our view, and we've based it on the fact that everything else that needs to be marked can be found in these standards, but that can't, and why would you need to know where the emergency lights are when you want to get out from the fire? You just want to know the lights on, and off you go. Okay, so that's sort of the symbols for the evacuation plans. What about the materials? Now, this bit, I think, just appeared in the last revision. I'm not sure. Keith, were they always photoluminescent?
No, only from the last revision.
Okay.
And the sizes as well.
Oh, the sizes.
The sizes and the floor area.
Okay, so photoluminescent is new, but it doesn't say what standard or what brightness, but it does say that it should comply with NFPA 170. NFPA 170 has a couple of tests for luminance in there. So So it actually defines what the material is through NFPA 170. Right? Just yell at the end if you want to ask a question. Okay, and the dimensions, let's just put out that there as well. Now there are a couple of tricks. Well, it looks straightforward, you know, less than 50 square metres for a space, that needs to be the size of the sign. But again, there are practical issues, like if you've got a 150 square metre area, the plan should be that big. But what if you've got the wall space in the right places? You know, it doesn't sort of, how do you get around that? And what we've put as a proposal is to say, well, okay, if you've got 150 square, let's go, if it's over 150 square metres, say it's 200 square metres, if you can't put one of those in, if it's 200, put 4 of those in different places, and it makes a lot more sense in terms of getting people out, not just to have one big one somewhere, but have them dispersed throughout the area. It's probably
Was there already a study regarding how the luminescence degrades from A1, which is from A1 to whatever next time?
Yes, there are numerous studies, and also a lot of these tests, like the test methods. What they do is they get the material and then they'll put it in total darkness for 3 days, so it's totally discharged, and then it'll have a controlled amount of charge, all at a certain, controlled temperature, and then the meter will actually work out what the luminance is over 6 or 8 hours.
Because I was wondering if you have these requirements. I'm not sure if NPA is always supposed to implement here in the Philippines. I'm not sure for foreign companies.
Yeah.
But what if your signage is going to be still tested after 10 years of its luminescence?
Okay.
You have to replace it.
Okay, so what you do, like they should have a durability test to show that you don't need to retest it after 10 years. Remember that I was referring to the HTC products, like a lot of them are warranted for 30 years and they don't run out, but they need to be tested to show that it is HTC. If it is HTC, you don't need to retest it because you've done the durability test. Does that make sense?
Yeah.
Okay. Exit signs. Okay, these are the 4 main standards which I've talked about before. Now this came up in discussion as well. So most of these standards use the ISO Running Man, but in the Philippines, the word exit is mandatory. You can't use the Running Man for a sign that goes above the door. Arguably you could at a low level if you had a low level system, but for these purposes we have substituted the word exit for the Running Man. But what we've done is use the standards to say what quality of material is used, how bright does it have to be, and what size does it have to be. And you'll see a couple of things coming up here. The other thing we had to do is try and clarify the definition of what sort of sign is it. This confusion happens in every country in the world because going back 10 or 15 years, you only had internally illuminated and externally illuminated. You didn't have this one. So, like, people started trying to put a photoluminescent sign into there or there. What has happened is the authorities worldwide are based on no, it's a third category. It's a category of its own, because externally, although the light for a photoluminescent sign, passive sign, comes from external, that's not what that's about. That an externally illuminated sign could be just a piece of cardboard with a print on it, but it has to have an emergency light that's going to operate for 90 minutes shining on it. Now, those sorts of signs are not used very much anymore for a number of reasons. One of them being that smoke reason, because if you have a light over here and the sign there that's meant to be lighting it, and you've got smoke, it's going to go up, it's going to block the light very quickly. So it's going to be even less visible than an internally illuminated one. Now, as I said, there's this hybrid sign, which starting signs, internally illuminated, photoluminescent, externally illuminated. You've then got this, what's called a hybrid. Some people call it a hybrid LED sign, some people call it a hybrid PL sign. But we've got one here, okay? Oh yeah. What a hybrid is it has the LEDs built into the sign. So the LEDs run off the mains, and it's sort of like an internally illuminated sign, in that an internally illuminated sign would be charging the batteries. The electricity fails, it uses the batteries. When a hybrid LED sign fails, it uses the photoluminescent panel. So we'll just put that on there and have a look at it later. But it's basically there are a set of LEDs in the box at the top. They run off the mains and continuously charge the photoluminescent material. So as soon as the mains fail, it's there. And the interesting thing about these is that you're able to reduce the number of parts in the device. So clearly there's no battery charging electronics. So that's the thing, one of the things that fails most in these signs. So you take all those bits out and they just last a lot longer. The LEDs in some test scenarios, they've been tested in a practical sense and are running for over 30 years without failure. So it's quite a step up. So just back to the definitions, just remember, like I'd normally put a hybrid LED sign in this area, but in some ways it is a PL sign as well, and the PL needs to be tested to make sure it is good quality PL. Again, as I said, we will email these out to you, so I'm not going to go through there word for word, but that's how we've defined the different categories of exit sign, and that's the common approach now worldwide. And there's a hybrid. As I said earlier, that the photoluminescent panel in there in the US is quite often called an energication panel, and so it's got an energication panel instead of a battery. That's the fundamental difference. There's one in situ. I'll say it's probably New Zealand. Look at it, but for all intents and purposes, they look pretty much the same as an internally illuminated sign.
Lagay natin sa pulo ng mangga.
Okay. So what we had to do is go, and again, when this discussion was happening during the break, where do you put different sorts of signs? What sign do you have to put where? How far are they spaced out? All of that sort of thing. it's not totally clear in the fire code, so again, we put this up as a proposal for interpretation to BFP. And we sort of hopefully will be getting some feedback and to get some certainty, because I heard it as a fairly common thing talking to everyone, it's that consistency of interpretation from enforcement officer to enforcement officer that gets really difficult and I'd say probably expensive. You've got to start changing things around. So we've said that the door, the sign above the door needs to be a hybrid or traditional internally illuminated sign which meets a suitable international standard. Then we've said, okay, there's that standard for the hybrid LED sign, and if it's a passive sign, that's the standard for a passive sign. And when I say passive, that means it doesn't have its own light source. So it's just sitting there, so it needs that 54 lux on the face of the sign for 60 minutes before a building is occupied. So depending on your type of building and the sophistication of a lot of buildings have got smart lighting systems, and the lights come up a little bit at 5:30 in the morning, and by 6:30 everything's charged and people start coming. Clause A6 is the section. It doesn't actually call it floor proximity directional signs. It's a little bit unclear. But basically, again, we proposed that this is talking about a low level or floor proximity signage system, directional signs and that sort of thing. So as I said, UL 1994 on its own, with no other parameters around it, will satisfy that requirement. Keith said there's some discussion with some places that everything has to be exactly 76 millimetres high. Or we said no other international standard says that. Let's say it's the minimum. Like most would be looking for 100 millimetre high sort of text or graphics for this sort of system. So we think that's where the 76 millimetres came from. So we say, okay, it's a minimum. So you need a sign, and I think there are there's UL 1994 signs there. They're all 100 millimetres high. So all those sorts of things we believe would meet that requirement. Then clause B sort of talks about the specifications of the sign. What are they made of? What do they do? So we've said as I said, the passive photoluminescent exit signs require 54 lux for 60 minutes prior and during occupancy. The externally illuminated signs, remember that they need 54 lux, but they also need the 54 lux on the face of the sign during the emergency. That's what makes them different. Photoluminescent, externally illuminated, two different things. The international standard NCC specification 25 is straight out of the Australian Building Code. It's been in that building code for over 10 years, I think, and it works. Remember I was talking about in that decay curve, remember that red line that I was pointing to was at 15 millicandelas. For these signs, the recognised minimum is 30 millicandelas. And remember, the reason for that is that you don't just have to see that the sign is there, you have to be able to read whatever is on the sign. So that's why that luminance requirement is higher. And also using specification 25, we've come up with the size calculations and the viewing distances which are coming up. That's all covered. So the size of the signs, it's all sort of detailed in there. It says that you need 150 millimetres in terms of text size, and then it sort of goes into this thing where an existing building, and then it says externally illuminated signs can be 115 millimetres. To tell the truth, I don't know where that would have come from. You know, if you're looking at an externally illuminated sign with the emergency light shining on it, I'm not quite sure why it can be smaller. Maybe just because it's in an older building and they're cutting a break for older buildings. Again, MCC specification 25 is the suitable standard there, and for the hybrid SATs 5367, which is the Australian standards Australia. Emergency over. Right. So, what does all that make? Rightio. So it talks about 150 millimetres high for the text, and it talks about what in the rest of the world is called a stroke width. It talks about 19 millimetres, and that's the sort of, it's defined in the font of what the width of the font is. So we've said here the stroke width is 20 millimetres because it sort of fits better to the usual sign dimensions. So 150 millimetres high, generally, so that specifically complies with what it says in the fire code of the Philippines. Luckily, that also fits on a sign that's 162 millimetres high, which means we can take that as a maximum viewing distance of 16 metres. Fundamentally, the bigger the sign, the further you can view it. So 150 millimetres, yep, we've got that, and we can then say, rightio, 16 metres is the maximum viewing distance for that sign. And then we've then gone to the size of sign from some of those other standards that's suitable for 24 metres. And all we've done is scale up the text, so it's now 210 millimetres high, and the stroke width has gone up a bit to 28, but it gives it a viewing distance of 24 metres. Now, most buildings, 16 and 24 metres is you can construct the system using those. We could actually go up to 32 metres quite easily by scaling all of those aspects up. We have it for this exercise, because as I said, this is packaged for just trying to interpret what's there now.
Question. I'm not sure with other places, but is there any place in the world the signage is required to have a translation? Except words in English word, Chinese word.
Yes, yeah, and it gets read again in the Middle East. We come up against this all the time. Yeah, because they want like the sign. They say if the sign's that size and it must say exit in that size, and it must also have Arabic. You go, wait a minute, where do you put that? You know, like so. Very common. Yeah, very common. And it really.
How does that affect the?
It makes it unreadable, I would say, you know, because everything's so small.
So we have to have a bigger signage now.
Yeah, which costs twice as much, you know, or maybe more. It is, so yeah, Middle East, even you know, French Canada is all, you know, sort of gets a bit like that. Yeah, many places. many places.
Do you have the experience like local bureau like requiring more than one languages?
In
In your
Philippines?
experience, yeah. Not maybe other countries.
Oh, in other countries, yes, yeah, like particularly the Middle East, yeah, so UAE,
What are other languages common aside from English?
well, Middle East is Arabic, but often, I'm actually gonna say, I think I've also seen them in Malaysia as well.
But I see in some of the, like for example in the Middle East, they put two signage, which is
Yeah.
English and then another one is Arabic.
Yeah.
So
Yeah.
I learned that we're using the standard signage.
Yeah. It's, but again, it's more expensive, yeah. Yeah, very,
Because we do not want to get to the point that to discriminate other languages. Why not in Chinese? Why not in Korean?
oh, right, yeah. Well, you know, like I would argue that ISO Running Man
Yeah, that's what we're
doesn't discriminate because it's not a language, but I'm pretty sure everyone would, most countries would recognise it. But I'm assuming the exit thing is a leftover from probably US. Yeah, there's a lot of US code, and a lot of clauses, like you said, sort of come from US documents. So that's how we get the two different sizes. That meets all those specifications of for size that are in the code. And then both sides of the sign, you can simply push them one way or the other and print the chevron on there. They'll still fit in the same size sign, whether it be 16 or 20 metre. Okay, so I think probably the exit sign area is the most. There are some unclear things, but again, the size of what they want is pretty clear. Right, so the tricky one, emergency lighting. This is, it's just a little bit. It specifically says that you can't use photoluminescent products to fully replace an emergency lighting system. So, okay, got that, we understand that. But we're saying what it can do is if your photoluminescent, if your emergency lighting system isn't quite up to scratch for whatever reason, and we know this from all around the world, there are maintenance issues with generators, there are centralised battery systems that are like there are lots of issues. Even older emergency lighting systems are so dull in terms of the luminance, that they're not really doing the job. So what we're saying is, okay, and this is really aimed at a situation where someone has a building and they're being told it's not up to scratch, or here's a cost-effective way that you can bring it up to scratch. Okay, so as I said, it specifically says no luminescent, fluorescent or reflective material should be used as a substitute for any required illumination. So we're saying, okay, yep, you can't design a system in a new building at a photoluminescent material and not have any emergency lighting. But if you do have an older system or something's gone wrong, we're relying on an ARC, remember, as near as reasonably practical to say you can build photoluminescent system aspects into it to actually make it safer. If there are not enough emergency lights, you can put photoluminescent material around to actually lift it up a bit, I suppose, is what we're saying. So I mentioned in Australia and New Zealand, you can actually replace a electrical emergency lighting fully with the photoluminescent system. So build new building, photoluminescent, yeah. So we've taken some definitions that are used there, and basically they talk about even the word emergency lighting has been taken out of the building codes in Australia and New Zealand, and they talk about emergency visibility. And the key thing that they say, they don't talk about this many lux or whatever of emergency lighting. They say that specified building features must be reasonably visible. And then they define what a specified building detail is. Feature detail, whoops. Not sure which one that is now. It means stairs and ramps. So the edge of a step, ramps, down the side of ramps, safety features, which the most common one are handrails, so they need to be made visible. Changes in direction, if you remember, which one put it back in there, but when we were coming down through the stairway, when the switchback on the stairs, you have the landing perimeter marked, and any obstructions you need to mark with like a piece of photoluminescent material. Most common in emergency stairways might be what do you call them, standpipes for the firefighting water. Yeah, yes, so yeah. And then it goes on to what is reasonably visible, and it says that it needs to be visible from 10 metres. So the edge of the steps, the handrails, and all these things, the material needs to be bright enough to be visible from 10 metres. And then they also say that, and this might seem unfair, but these systems are never designed for people with impaired vision or sight, because they say, no, a different part of the code looks after those sorts of things. So they define it as 10 metres for a fully 2020 sighted person. I'm not sure it does need to be 2020, but it's quite close to that. Okay, so clause A talks about the means of egress, and that includes the exit access, and the exit discharge. Now, often the exit discharge is outdoors. You go out the exit door and you're on the first floor, you're taking the stairs down to the outside. Those stairs can be incredibly difficult to wire and get emergency lights there and keep them going because of the weather and all that sort of thing. So this is where we have proposed, if it's an outdoor stair like that, use the PLC high luminance test and put material on the edge of steps. Can't quite see it there, but it's on the handrails and on the landings. And if it's getting daylight, and remember it doesn't need to be direct sunlight, if it's getting daylight, it will be visible all night. I forget the latitude number, but you know, if you go to the North Pole, it's not going to work because in the middle of winter it's dark there 24 hours a day. But I've had a look, and I know New Zealand down going south is all well within the latitude, and the Philippines is easily all within those bounds. And I think I just got it. That's what the system looks like if it is dark. Now, I know, like, you can argue what never gets that dark in the city, outdoors, but we're talking about something where there's been a major power outage, earthquake, something like that. Storms probably take out the power as well, and this will be visible. At least fail-safe. Believe me, for 20 years I've had it around my home, and to the point where my wife starts complaining because it gets too much at night. A few arguments. Again, just back to that, if you've got, you know, older lights or emergency lights, sometimes you'll see them, they have what they in the US are called the bug eye ones, where there's a couple of emergency lights. They'll commonly be, you know, up here somewhere, shining down the stairway. Now, that's probably not going to be great with a crowd of people going down. Again, you know, put some material on the edge of the steps, on the handrails, and it overcomes that. So again, you can't design a system like this to replace emergency lighting, but you can use it to bring the current emergency lighting system up to speed. Okay, clause B, sources of illumination, talks about reliability and, you know, needs to go for 1.5 hours. I think I mentioned earlier, there are issues, especially if systems aren't well maintained, but there are reliability issues with generators for sure. I know, probably tell I've been in this business a long time, but in the early 2000s, the common thing that was quoted was a big earthquake in San Francisco, I'm going to say late 80s, early 90s. Basically 80% of the generators in San Francisco failed. They didn't come on because the whack and the shock of the earthquake just gave something a nudge, whether it be wiring or something, and they just didn't fire. So that's, I think, part of the reason that there's such a push for these systems in the US now. They've seen things go wrong. Again, same standards here. Again, you need 54 lux, 60 minutes to reach the minimum charge. Now, these systems, and actually we've included all the research with this guidance document of all the studies that support these claims, but egress speeds increase if you have photoluminescent material. Systems also highlight temporary obstructions. So remember earlier I said that an obstruction or hazard within the stairway needs to be marked, say a standpipe or something like that. Yep, you can see it's there. But what about everything else? What if, you know, you're going down the stairs and someone drops their bag and can you see it? Again, there are studies that show that the temporary obstructions, that's what we call left behind baggage and shoes and stuff, you can actually see them as you're walking down because, of course, the edge of the step is this black bit in the middle. And the last thing, again, the floor-based systems increase visibility of the smoke because the smoke's going up. You've seen this one before. Yeah, it's just the smoke. Photoluminescent system, some smoke with lights on, and smoke with lights on. Clause C refers to the changeover time of the lighting, emergency lighting system. 10 seconds is pretty common around the world for startup time, minimum startup times for generators. It isn't always possible. So the thing with photoluminescence is that it's instant. So if you have got longer startup times or changeover times, like you don't want it going totally black for 20 or 30 seconds because that's long enough for people to start panicking. And once they panic, they don't unpanic very well. So if you have photoluminescence on steps and handrails, they've got an immediate frame of reference and they can actually start moving, and then the generator or the battery backup system gets going, and everyone's in a better frame of mind, moving at a good solid speed to get out. I just keep reminding, you know, that any of these systems, they need 54 lux for 60 minutes to get them to the minimum. Over that time, they just get better and better, I suppose. The other thing that photoluminescence does is recharges really quick, and I mentioned this earlier, you know, whether it's a exit sign or emergency lighting system, they do take a long time to recharge once they're fully discharged. 16 hours is sort of the mark that we use, because that's the maximum recharge time that's allowed in most standards, emergency lighting standards around the world. So generally 16 hours. 16 hours is good. Some of them are a lot longer. You know, old systems can be 24 hours easy to recharge if they're totally been drained. Photoluminescent systems, if they've been totally drained, that means in total darkness for 3 days. That's how long it takes to. Then it'll take 54 lux for 60 minutes. Right? So you're always getting, as long as you are getting some light in there, you're going to recharge much, much faster. Okay, so that's sort of the products, the clauses, but if you actually want to use these sort of products, how do you actually design and specify what you want? Like most manufacturers will have like a master format specification document. I haven't seen master format used a lot in the Philippines, but it's again it's an American system of structuring all the requirements for materials, and the master format, they actually have a section number, so you get a manufacturer will be able to give you a Word document, and you just copy and paste the bits into your design document. That master format spec, it's a pretty long document, and it goes through a lot of stuff. It even defines what samples you have to provide and all sorts of stuff like that. So some manufacturers have got a rapid spec doc, which is sort of the cut down bit, and it's just what does the photoluminescent material have to do, and what test certificates do you need to see. So that's the rapid spec doc. Performance, you know, always look for third-party testing if you can, like UL, all the UL stuff. You can actually just go to the UL website and look for products certifications. I think Keith, I don't know whether people use it, but I think you can search Ecoglo and it'll take you to whatever it is there, is it?
Yeah.
It'll take you to whatever certificates are held by that company or that brand. ISO 9001 quality systems, that is pretty standard. I don't think any manufacturers will be able to sell into North America or even the Middle East, and they're pretty tight on the terms of saying you've got to have a QA system and a certified QA system, an audited QA system. Something else to look at. And that may well have been the most boring, dry topic, but that's the end. So I hope you have any questions. Like, don't know, we have to run off. Sure, the 10 coffee's still out there if you want to hang around if you've got specific questions. Keith, I think we have the email addresses.
Yeah, we do.
Yep.
So we'll send them the stuff, and probably before we send it to them, maybe if you wanna explain to them that we'll set up that.
Oh,
we'll
yeah,
put
yeah,
them on the
so,
technical
yeah,
group.
so you can actually have a closed group on Facebook. I don't know whether you follow, his company on Facebook, but you can have a closed group and we're gonna set up a technical group where, so it's not open to the public, but you just apply and you know, get approved and people can ask questions and, I suppose be a bit, you know, you're not in a total public forum, so you don't have to say, oh, I've got a building that doesn't comply and this is where it is, that's a bit public. You can sort of talk about issues and things in a bit more openness than if it was a totally public forum. So, and I think you'd probably be able to email out an invite to that as well. There's also, like, you know, anyone want to take a totally deep dive, you probably, you know, wouldn't just email this out to everyone because it's pretty dry. But if anyone really wants to take a deep dive into it, I'm sure we can arrange that as well. Okay. Well, yeah. Got any questions later? Let us have them, and thanks all for coming. I know, yeah, it's a holiday, and like,
Question please. That 54 lux, is that the standard?
yeah, that's UL 1994 and UL 924, all specified in the test method. 54 lux for 60 minutes.
So 60 minutes.
Yeah. So that's to charge a photoluminescent system. It's not like saying you need 54 lux of emergency lighting. It's simply to charge the photoluminescent sign or the material on each of the step. So it's assuming that you're in a totally dark, enclosed area and that the material is fully discharged, which takes 3 days. So it's quite a conservative way to measure it, but that's what it says in fact on the UL sign. I think it even says, did I say the UL one?
Yes.
Yeah, I think it says you have to print it that you need, maybe in America, in the US it says 5-foot candles for 60 minutes.
Though in addition to that, like, it's kind of not specific, like, lux, at what distance to the floor directly.
Okay, so it always says
Reading if you have a light meter, right?
Yeah. So,
From what specific spot?
from the surface of the photoluminescent material. So if the sign's up
Yes.
there, you got to put the
Direct.
lux meter up there. If it's on the floor, you put the lux
It's what
meter.
distance of that?
It doesn't matter.
Yeah, that's why.
Yeah, because
As you go further, it's going.
Yeah.
So the 54 is not really what spot is.
Well,
that?
yeah, it's what it means that it has to be 54 by the time it gets there.
Because my interpretation, maybe it's just right below.
No, yeah, it's got to be
If
on the
the exit
material.
sign is-
Yeah, it's got to be on the material. Yeah,
Right below.
Yeah, whether it's on
To
the
the
edge
floor,
of the
yeah.
step or on up on the wall. Yeah.
It doesn't say that, it's vague, right?
Well,
It doesn't say directly
yeah,
below.
usually, I was paraphrasing
Yeah,
some
no,
of
it's,
those things.
whether
And,
the code doesn't specify.
the Philippines code doesn't,
Yeah.
but those the standards do. Like the UL 924, UL 1994, NCC, specification 25, they'll always say on the face of the sign, or on the,
Below.
yeah. But yeah, good point, it is, yeah, I wasn't putting all the words up there.
That's okay.
Although there's a written standard, like 54 lux, from my experience, I don't know with other people here, 54 lux, is that the standard that you have to meet? Minimum standard you have to meet
Yeah.
when it's already installed in your establishment, right?
Yes,
In the building.
yes.
So what needs to be proven if you have 54 lux is that you have a proper ASTM procedure on how you are going to test the 54 lux,
Yeah, so there are a couple of
The
different
testing
ways.
commission, testing commission.
the tools,
Yeah.
the personnel, the trained
Yeah.
personnel.
Well,
Doing the testing
yeah,
commission.
like in a design process, like most new buildings now, the lighting engineer will have a lighting model, and they they just dial it in, and it gives you all the lux readings everywhere. So that's how a new building would be approved, because those plans would have to be approved and signed off, right? And an older building, like a lux meter,
I didn't bring one.
no, a lux meter is, $50. And it's, you can just turn it on, put it on down, you can easily see. Like 54 lux is not a lot of light, it's quite a low amount of light. Like, down there I would say would be, might be 1,000. Or quite a few hundred.
I'm not sure if we really measure that.
No, it's not like, I would say in a practical sense, you get a bit of product, you put it down somewhere, and walk away and let it charge, come back, turn the lights off, and you can see it. Like, it takes a long time, you remember that cable, it takes a long time for it actually run. But that's